Hello my dear students, so welcome to my YouTube channel. So this video is for the general trend of different properties in the period as well as the groups. Okay, so here what happens, so there are so many trends. Like in a class 11 you might have studied the chemical properties, periodic properties of the elements. Okay, so there are so many periodic trends we have, like atomic radius, ionization potential, electronegativity. Okay, so like a basic property, acidic property, covalent character, metallic. So what happens, it gets difficult to remember all those concepts. Okay, here is an easy way through which you can like remember the periodic trends. Okay, what happens along the period, what along a period, what happens down the group, we can see and we can remember very easily. And one more point, dear students, there is a quite a relation between the different trends. Okay, if one trend is increasing and another trend will be decreasing, they are related in such a way that even it gets easy for you people to remember. But until and unless we don't know anything about these things, like what do you mean by atomic radius, what do you mean by ionization potential, so when you don't know about these things, obviously it gets difficult to remember even if I give a easy way. Okay, so please do concentrate and do watch till the end of the video, so that you will going to get all the information regarding what are all those concepts and how they will going to change along a period and down the group, and how they are related with each other. Okay, so let's start with that. So dear student, the first one here is, see, one more thing I want to repeat here. I have taken how many, like 6 trends I have mentioned. Like this, there's so many trends. So the next another 2 videos will be about the remaining trends and how they're going to change. Okay, fine. So now the first one is atomic radius. So dear students, so you know already atomic radius, ionic radius. Okay, so like a covalent radius. Okay, so what do you mean by atomic radius? So you know the atom. So here I'm going to use some space. Okay, so you have an atom, as you know, an atom having a center of which is we're going to call as a nucleus, where you're going to find a protons and neutrons, and electrons will be revolving. Okay, so this is an atom. Okay, so there is a distance between the center of the nucleus to the outermost electron. Okay, the distance between the center of the nucleus to the outermost electron, this distance is known as the atomic radius. Okay, now what happens along a period down the groups means what is the trend of this atomic radius. So dear students, so we know that as we go along a period, okay, the number of electrons increases, that we know, and electron will enter into the same shell. Okay, so here what happens, electron will enter into the same shell. As the electron will enter into the same shell, so dear students, the distance will not increase. What happens, the force of attraction increases between what, between the center of the nucleus and the electron that is entering. Okay, as the force of attraction increases, obviously what happens, you could see here what happens, the attraction goes on increasing, so the size start shrinking. Okay, the size of an atom start decreasing, you can use that word also. Okay, so you should know that along a period the atomic radius decreases. Okay, now what happens down the group? Down the group it increases. Why it increases? See, as we go down the group, the number of shell increases. Why? Electron will start enter into the next shell. Okay, so it start entering into the next shell. So as the number of shell increases, the distance between the center of the nucleus and the outermost electron increases. Okay, obviously size increases, obviously atomic radius increases. Okay, this is the first what I can say, the trend, the important trend you have to remember. Okay, so I'm repeating, atomic radius along a period decreases, down the group increases. Okay, now come to the next one, that is ionization potential, or you could say ionization energy. What do you mean by that? See, it's an amount of energy required to remove an electron, okay, from a outermost orbit, I could say, or from remove a valency electron from an isolated atom. Okay, so I have an atom. Okay, now what I need to do, I need to remove the outermost electron that is present. Okay, so I need to remove what? The outermost electron that is present. So is it easy? It is like if I tell and the electron will come out? No, you had to spend some energy. Okay, so to remove an electron, I need energy. So how much energy you will going to spend to ionize an isolated atom is known as a ionization potential. Okay, so it's a quite obvious, dear students. Smaller the size, so you could see here, along a period what happens? The radius or the size decreases. So smaller the size, dear students, what happens? The outermost electron is strongly held with a nucleus. Okay, if the outermost electron is strongly held with a nucleus, so the force of attraction is more. So it gets difficult for the electron to come out, or it gets difficult to remove this electron that is present because it is strongly held. Obviously, what you need to do? You need to spend more energy. Okay, so along a period, ionization energy increases. Okay, now why down the group it decreases? It's quite obvious, dear students. Down the group, the size increases. As the size increases, the outermost electron is left free. Okay, so it is not that much strongly held, so I can remove very easily. Means I need to spend very less energy to remove that electron. Okay, now dear students, there is a relation between the atomic radius and the ionization potential. Inversely proportional, you had to remember this one. Okay, they are inversely proportional. Means smaller the atomic radius are, you could think like it's a size as well. Okay, smaller the atomic size, more will be the ionization potential. Means smaller the size, more energy you need to spend to remove an electron. Larger the size or more the atomic radius, lesser will be the ionization potential. Ultimately, what you need to remember, the atomic radius and the ionization potential are inversely proportional to each other. Very, very, very important. Okay, yes, I hope you understood about the atomic radius and ionization potential. Next comes electronegativity. Okay, see here, what do you mean by electronegativity? It is a capacity to attract a shared pair of electron towards itself. Okay, more the electronegative character means more will be the attraction. Okay, an atom will going to attract a shared pair of electrons towards itself. Okay, it is what I can say, a qualitative character, I could say. Now what do you mean by electron affinity, dear students? It is the amount of energy, okay, amount of energy released when a shared pair of electron is added, okay, or attracted. So there is I could say electronegativity is a qualitative and electron affinity is a quantitative character. Here electron affinity will give you how much amount of energy released. Okay, so electronegativity is a qualitative character. It's a attraction of a shared pair of electrons. Okay, you can measure in a kilojoules per mole, and you can measure electronegativity by using a Pauling scale. Okay, now dear students, what happens to the electronegativity along a period down the group? You could see there, electronegativity along a period increases. Why it increases, dear students? Again it depends on the atomic radius. Okay, so what happens? Along a period the size decreases. Okay, obviously as the size is small, dear students, as the size is small, if electronegativity means what? Attraction of a shared pair of electrons. If the size is small, obviously the incoming electron will find more attraction towards the nucleus. Okay, obviously the electronegativity increases. Why? Smaller the size. Okay, so what happens down the group? As the size increases, dear students, Already the outermost electron are free. They are not finding more attraction. So the incoming electron will not find more attraction. So it decreases. Okay. Now how? What happens? Next come to the electron affinity. Okay. So what happens to the electron affinity along a period? It increases. So along a period, electron affinity increases. Okay. So quite simple, dear students. Electronegativity and the electron affinity are related. Okay, how they are related? They are directly proportional. So more the electronegativity means more will be the attraction. More the attraction means more will be the amount of energy released. Okay, so electron affinity increases along a period and decreases down the group. And how they are related, I have shown here. You have to remember this one. Okay, now here I forgot to tell about this, how ionization potential and the electronegativity are related. Ionization potential means amount of energy required to remove the electron. Okay, so quite simple. More the electronegativity, more the attraction of a shared pair of electrons, more will be the amount of energy I need to spend to remove that electron. So they are directly proportional to each other. Okay, even we have, like, I hope you have understood this concept also. Now let us move to the next concept, that is a covalent character of a halides. Okay, so what do you mean by covalent character? What do you mean by covalent bond? It is a bond or the character which involves the sharing of electron. Okay, so what happens to the covalent character of halides along a period, dear students? It increases. Along a period, covalent character increases. Why? Because of the smaller size. Okay, so electrons are strongly held. Okay, so strongly held, obviously the covalent character increases. Okay, so as we go down the group, what happens? The covalent character decreases because of an increase in atomic size. So you could see here, each and every property ultimately depends on the atomic radius. That point we have to remember. Okay, now what do you mean by metallic character? Dear students, we know that metals are the good conductor of heat and electricity. That's a point we know. Okay, why they are the good conductor of heat and electricity? Because of the availability of a free electrons. Okay, metal consists of a free electrons. Okay, they are rich with the electrons. So more the electrons, more will be the metallic nature. Okay, now what happens? Along a period, metallic character decreases. Why it decreases, dear students? As we all know, the size decreases. Okay, as the size decreases, obviously the electrons are strongly held. Electrons are not free. They are more attracted towards the nucleus, so that the metallic character decreases. But as we go down the group, the atomic radius increases, the size increases, and electrons are free. So more the free electrons, more will be the metallic nature. So as we go down the group, the metallic nature increases. Now, how the covalent character and the metallic character related? They are inversely proportional to each other. Okay, more the covalent character, more will be the stronger will be the electrons held. No free electrons are present. Obviously, metallic character decreases. Okay, lesser the covalent character, more will be the metallic character. So this is how the trends are related with each other. And one point you might have observed here, each and every property depends on what? Depends on the atomic radius, or I could say the size. Okay, so this is about the some general trend of different properties in the period and the group. So as I told, I have taken only 6 property here. So in my upcoming video, you could see some more property and how they are related. So dear students, do practice this one, because this finds very much application in your competitive exam, and you have to remember these relation. okay, which is very, very, very important. So if you practice once or twice or thrice, it will be stuck in your mind very easily. Okay, I hope you find this video. Please do wait for the next video. Thank you so much.